Welcome to the instructions on the final assignment for the AutoGIS 2021 course. The final assignment is what we have instead of an exam in the course. So you will be doing a final project where you will show off the skills and practices that you have learned in the both GeoPython course and in the AutoGIS course. So what I'll do now is go through both, recap a bit what we have taught and what you have learned in the AutoGIS course, to kind of refresh what you should think of when doing the final assignment. And then I'll introduce the different topics that you can choose from. And then in this slide deck that I'll also post to the website, there are also some tips and tricks and some useful links for you to check out. And then I'll briefly take a look at the GitHub repository where your final assignment will be, and how you should submit that. Okay, but so the main goal of the final assignment is to replace the exam in the course, and the main goal for you is to show what you have learned and practice those skills as well. So in this AutoGIS course, we have gone through how to work with geometric objects in Python and in Shapely. We have managed spatial data using GeoPandas and done some operations with those data joined from different data sources, read files from different sources, and also written those data to files. And underneath all of this, also been working with CRS and projections. And then we have also been doing some geocoding and doing some spatial queries with our data. We have also reclassified data based on different parameters and done some overlay analysis. And then last week, we have been creating our visualizations, both interactive and static maps. And then also next week, we will be using OpenStreetMap data, fetching data from OpenStreetMap, doing some network analysis with that. So even though that lecture is next week, you can also use that in the final assignment if that is something you would like to do. And then we also, on the website, I posted today some extracurricular content. So there is a section on doing raster processing if you, for example, want to work with satellite data, how to do that with Python, and then also a section about using Python within QGIS, if you are interested in that as well. All right, so in the course, the main learning goals that we have had have been for you to create modular code that can be repeated in a way that you don't necessarily have to write the code over and over again, but that you can run small snippets of code that can be reused, like when we have created different functions for our data and applied that to different data sets. We have, or you have, one learning goal has been for you to be able to manage spatial data programmatically in how to read different data formats, how to reproject them, how to reclassify, and how to store the different spatial data sources. And then also how to do different analysis steps and methods, how to do some spatial joins, how to do some buffering, and next week, how to do some network analysis on our spatial data. And then also, you should be able to create different charts and graphs and maps from our geographic data in Python. And on an overall level, you should be able to design and implement a data analysis workflow using geographical data. So in the final assignment, it's good if you are able to kind of showcase that you are able to do all of these different aspects that you have been taught during this course. And in addition to that, these specific learning goals, we have also had some goals of some generic skills that you hopefully have been able to improve and expand. So that has been searching for information on programming methods, applying different methods based on the documentation, both on the course web pages, but also on other online documentation for different packages that we've been using. But also how, if you search for information about programming methods, that you are able to critically evaluate those different sources that you come upon and all the different methods that are out there. And we also wanted you to understand how version control works in a sense, and how it can be important for both practical tasks, but also in a scientific purpose way. And we also wanted you to be able to communicate analysis workflows that you're using in a written format. So both in terms of describing your steps in, for example, a README file, but also documenting and commenting your code as you go along. And yes, we had a final or a last generic skill to complete assignments on time. Yes. So what are you supposed to do in the final assignment? You can split that up into three different aspects. So in essence, what we want you to do in the final assignment is to develop a GIS analysis workflow using Python that includes three different steps, or like three different overall aspects. So the first is data acquisition. You should be able to read data from either from files or from some online source, like a web feature service or something like that. You should do some analysis on that data, enrich that data, and conduct some spatial analysis like spatial joins, buffers, overlay, network analysis, some of the analysis methods that we have used in the course. And then you should also visualize the results from that analysis as maps and graphs, and preferably more than one of each. Yes. So the final project is split into, you're able to get in general 60 points for these three different aspects. And then also, if you show good documentation of your work, both your processes and your code and your analysis workflow, you are also able to get 10 points for that. And then also there will be other extra points if you can show some extraordinary analysis or extraordinary maps, visualizations, or something like that. But there are also more instructions on all the grading on the course web pages that you can check out as well. But this is the overall picture that we are working with. Okay, so in your assignment, when you're doing this, the structure of the final project of yours will be a repository on GitHub in the same manner that the weekly exercises have been. You will create either a set of Jupyter Notebook files or Python script files, or a combination of that, where that shows the processing steps and your Python workflow. And then in the README file of the repository, there you should present all the relevant information about both the process or the workflow that you're using, but also links to files, information about where you obtained your data, or some literature, scientific literature, if you're relying on that as well. That is a good thing. And then in your repository, it's good to, or you should remember to document your work, use good coding practices like informative variable names, inline comments, doc strings, and just like a note that is good to remember is that GitHub has a file size limitation on your files. So if you are working with large files, then it's a good idea to present or to upload only a subset of your data, for example, and then show that how you can work with that data also for other files in the same data set. So if, for example, if you're using the travel time matrix, then you don't want to upload all the different files from the matrix up to your GitHub repository, but upload a few different that showcases how your code works for the different input files, and that in theory you could exchange it with any of the files in the travel time matrix, and your code would still run and work. And then there's a question in the chat if the source data can be geological data, and that is totally fine. I'll get back to the topics later, but basically there is a topic you can choose for yourself freely, as long as you discuss it with me or one of the teaching assistants. So the main thing is that the underlying data doesn't matter that much, as long as your code showcases geographical analysis steps and methods in Python. And so yes. Okay, the last admin part on the final assignment is that we operate with two different deadlines. It doesn't matter which one you choose. It won't affect your grading or anything. So it will only affect the time when you get your grade. So if you choose the first deadline, which is at New Year's, I will start grading those right after New Year's. And if you choose the second deadline of 16th of January, I will start grading those after that. So you can choose whichever you like. If you want to have a holiday break, you can choose the latter deadline. But if you need, for some reason, need your grade earlier, then it's also a possibility to submit by the end of this year. And then the course grade will be made up of the exercises for the during the semester, but also the 60% will be from this final assignment. Okay. Are there any questions at this point? If not, then I will continue to the different topics for that you can choose between. So basically, we have 3 different topics for you to choose from. Or put in another way, there are 2 different topics that we have in a way prepared, and then a third one that you can choose quite freely what you would like to study in the final project. But I can start with the 2 topics that we have prepared. So the first one is called Access Viz. So the object or the objective of this task or this topic is to create a Python tool for managing and analyzing and visualizing the travel time matrix. You will then create different Python functions and show examples of how you use these functions in the notebook and or Python script files that you create. So in this Access Viz topic, you should create at least these 4 different components for accessing the files of the travel time matrix. So a file finder, and then one component that joins the attribute data to the spatial data, doing some spatial joins, and then doing one visualizing component that creates some maps, and then a component that compares different travel modes. So public transport and car transport, or different travel modes in the travel time matrix. And then there are also 4 other optional components that you can choose to add to your analysis. And these are listed on the course web page. So I encourage you to after we're finished with this lecture, to go to the course web pages and read more about each of the specific topics. But this is just to give you a short introduction into what the topics are. Okay, so the next topic is a bit more fussy, but it's called urban indicators. So in this topic, you are to develop a urban analytics tool that where you look at least 2 to 4 different indicators in an urban area and apply those analysis to 2 different cities or neighborhoods. So you could either look at different metrics and indicators. Some of these, the ones you can, or some examples are listed here. So you could look at the population distribution and demographics of an area, or of Helsinki as a whole and Tampere as a whole, for example, or 2 different neighborhoods in Helsinki or another city, and do this for 2 to 4 of the different indicators. Some of them are listed here, but that could also be other indicators if you find something interesting that you also find data for example. Yeah, so there's in this topic, there's also some room for you to both choose the different indicators that you find most interesting and also the study area that you would like to look at. Okay, and then the last topic is your own topic. So so this is basically quite free. You can come up with the analysis workflow that you would like, but you should also, in this topic, check off the 3 different main categories or aspects of fetching some data or reading data, enriching that, doing some spatial analysis, and then also visualizing in different maps and graphs. So if you choose this topic, please be in touch with either me or the course instructors or teaching assistants before, preferably the beginning of next week. Then we can give a thumbs up and a go if it's fits in within the realm of the course. But I'm sure it will. But yeah, get in touch with us if you have your own idea and want to start working on that. Then I'm sure we can find a way that works out. So that was the quick introduction to the 3 different topics that you can choose from. So here is this section of the slides are some tips and tricks that I recommend that you go through on your own. I will briefly scroll through it, but first of all, here are some best practices that I recommend you to take a note of and check if, especially before you have your whole final project set out, take a look at this article on best practices in scientific programming. They are quite handy. And then here's also a checklist that you can come back to both in the planning phase, but also as you go along with your project, and in the end to see, do I check off all the different aspects that is needed in the final assignment. So I recommend you to go back and check this, not just at the very end. If you then figure out the extent of the work is not sufficient, then it would have been better to check that in the middle of the period or beforehand. So yeah, go over this a few times. I would recommend you to do. And then we also have some additional resources and stuff that we didn't have time to cover in this course, but that are also perfectly relevant and something that you can also use in your final project if you like. So like I mentioned, there is the lesson on the course web pages on raster, working with raster data. So you can check out that. But there are also other relevant sources and resources that you can use and check out. So I recommend, if you want to work with movement data, for example, then there's a package and module called Moving Pandas that is useful and powerful to do that. And then also Plotly Express for doing interactive maps. And Plotly is basically also a visualization library. So there are thousands of others other different charts and visualizations that you can do, but they also you can also create interactive maps in that sense, or with that module. And then also, yeah, if you're working with raster data in the end, Data Shader is also a good source to check out for that. Okay. Are there any questions at this point? The next thing I will do is go to the course web pages and then find the GitHub repository that you will be using. And that is more or less it for today. But just shout out if there is a question or anything you want me to cover. But if not, I'll head over to the course web page, which is here, the final assignment. So here, all the different aspects is also described, and you can check out the different topics as well. The access this tool is described in more detail, for example. Yeah, and also the urban indicators as well. But as always, the way you do the assignment is to go to GitHub Classroom and accept the assignment, and then your repository will be created for you, and it will look like this. So it's a empty repository except for the README file, and here are also some instructions on what this assignment or repository should contain and how you should do that. When you are finished with your assignment, you can remove this part of the README file to make it more clean, and then you can fill out. You can even start filling out the topic and kind of describe what you want to do in the README file in the bottom here, and there's a room for you to describe what you are doing, what input data you are using, what analysis steps you are utilizing on your data, some results that you have, and links to different maps and interactive maps that you end up creating, and then also some references if there's literature to that you base some of your decisions on, where you obtained your data, and also if you have been getting tips and tricks and collaborated with other students, then you can mention it here. It's a good idea, so that we are aware, as one of the best programming or best practices of programming. One of the points there was to collaborate. So even though this is a individual project, you are allowed to ask other students for tips and tricks. But then it's also a good idea to give credit for that. And also this indicates if we see that, or it indicates so that we can see that you have not just plagiarized other students, but that you have collaborated in a way. But remember that it's an individual project that you get a individual grade on, but also allowed to get tips and tricks from other students as well. So yeah, the way that the two different deadlines work is that right after the first deadline has passed, I will check your repositories to see if you have checked the submitted button, or if you're still working on the final assignment. So the way you can do that is to click on the edit button and just put an X in the submitted, or you can put a small X in the submitted brackets and remove that one. And if you commit now, then the submitted check mark will be there. And then I know that you are finished and I can grade your repository. Yes. So that was it for today. I will stop sharing my screen. So that was more or less the final assignment in this course. Remember, it's replacing an exam, so think that you put in the amount of work accordingly to show all the different skills that you have learned during this course. And then next week, we will have the last lecture with Woko Hekinheimo on OpenStreetMap and network analysis, which is a good and fun topic. So see you there.